Hi, my name is Leonardo Zamaripa. This is Victor Lay, Kenneth Wynn, Nick Sanders, Ian Borgen, and Cho Chen. We're all electrical engineers. And for this year, we decided to work on an electric bike. Although electric bikes are good for keeping the environment clean and are more cost effective compared to their counterparts, the electric car and gasoline-based cars, etc. The downsides that they have is that the distance that they can travel per charge and the inconvenience and inaccessibility to charge it at, let's say, a workplace or a friend's house makes it a not viable option compared to its counterparts. And therefore, to increase the amount of distance that we can travel, we decided to use alternative energy sources such as regenerative braking and solar power to increase the distance that we can travel. Our goals for next semester is to design an electronic speed controller with Raspberry Pi, use pulse width modulation from the Raspberry Pi to control the BLDC motor, to have a system that works with regenerative braking and has solar panels that are used as an alternative energy source for the battery. Also display the distance and the speed with an LED display.
Right, on performance, we're looking at about a range of 15 to 25 miles per charge. The measured distance is about the accuracy, about plus or minus 5% on the display. Our solar panel power is about 25 watts on an ideal case. And then the solar power recharge is we want the battery to be around 20 to 25% ideally.
So I'll be talking about the three components of the overall system. So we have power management controller, which is the Raspberry Pi, and a feedback system. So the feedback system is composed of the Hall sensor, which will send information to the controller in order to determine what is necessary. So the Raspberry Pi controller will take the information from the Hall sensor to calculate speed, distance, rotation, and those information will be displayed to our live feed, which is the display. In addition to these information, we want to make sure that the motor runs smoothly and as expected. So every single time, so we can adjust the speed of motor necessarily, and not just have it run however it wants. And so by controlling the motor, we're using regenerative braking and a motor driver in order to change the speed and charge the battery. So with regenerative circuits, when the bike brakes, it'll produce energy, and that energy will return back to the battery, and that's where that circuit comes from in the bottom left. In addition, by using pulse width modulation by the controller, the transistors act as switch, which in a sense make the pulse width modulation that is powered by the battery. And lastly, the power management. So the solar power powers the battery, and the battery powers everything else. We want to have a power management where every single component is powered necessarily with this correct amount of voltage and not getting damaged by any overcurrent or any back current. So we're open for any questions.
So do you, for your regenerative braking, use a brushless or a brushed GC motor?
Yeah, so the BLDC is a brushless DC motor.
Brushless?
Yes.
Okay. How heavy is it?
I'm not quite sure.
It's about 5 kilograms, I think.
One question, I'm kind of old-fashioned. Usually if you buy a bike, you want to use it for exercise and stuff. Is this going to be transferred over to a different type of vehicle?
So these components are actually transferable. Like this, there are kits online where you can just buy the parts and install into their bikes. But the thing is, as for exercise, I think people use electric bikes for the sake of traveling long distance and not having to exercise in the first place. So it's more for convenience and distance rather than exercise.
Yeah. Would it also be used on something like a moped or something?
Yeah.
Light vehicle type?
Yeah.
Okay, that helps.
So what kind of you got some range? What about speed? What do you think your cruise speed or whatever is going to be?
So
Legal speeds.
Yeah, okay.
Yeah.
Well, can they even get that high, or is it a problem?
yeah, you can get that.
The legal limit that we have is 20 miles per hour with
Okay.
just the motor, but we
Okay.
can pedal and go faster, up to 25, 30 miles.
Okay, but 20 is typically where you guys are targeting.
Yeah, we're capping now at 20. We don't want to break any laws here.
Is your range, do you get more range from the solar panel or from the regenerative braking? Which is contributing more to?
The regenerative braking, depending on if you're braking a lot, can give up to 5%, right? And the solar panel can give up to 20 to 25%. So the solar panel is the biggest increase it, but the regenerative braking is just to add a little bit more extra distance.
And how big is that solar panel, just curious, roughly?
I believe it's about two.
It's about the size of a textbook.
Yeah.
2 feet.
Okay, thank you.
No, 1 to 2.
All right, one last.
The 20 to 25% unit you have there, is that of the total power?
Yes, about, the goal is about 200 watts or so. of
200
the
watts
battery.
from the solar panel?
Yeah.
Of the total load?
Yeah.
Okay.
In an ideal case of 8 hours of charging, 200 watts.
Okay.
Um,
All right, let's thank the team.